Welcome to Study Loop.
So now we'll work on problem 90 from chapter 17. Here we're given three molecular formulas, generic molecular formulas, as well as their molar solubilities, and we're asked which of them has the smallest KSP. So for A, we have the compound AX. So KSP in this case will be equal to S squared when we have this 1-to-1 ratio, which if we plug in the molar solubility, which is 1.35 times 10 to the minus 4 squared, we can multiply here to get a value of 1.82 times 10 to the minus 8. So if we go ahead and do it for part B, we have a formula for AX squared, AX2. And so if we have this, we know that the term for KSP will be equal to 4s cubed. And we can plug in our molar solubility, which is 2.25 times 10 to the minus 4 cubed. And when we solve this term, we get 4.56 times 10 to the minus 11. And finally, for part C, KSP, we have this time A2x. So the term will be the same as for AX2 because it doesn't matter if it's the anion or the cation, the term will be the same. And so we can plug in the molar solubility, which is 1.75 times 10 to the minus 4 cubed, and we get a value of 2.14 times 10 to the minus 11. So if we're looking for the smallest, we can check off part C. Now, if we're looking at the problem, we don't really actually have to solve every problem. If we recognize the terms that we're going to use for A, B, and C, we're going to use S squared for A and 4S cubed for B and C, then we can see right away that A will not be the smallest because we're only squaring this small number. We're not cubing. And then once we realize it will be one of the ones that we're cubing, we can see that C has the smaller coefficient in the scientific notation. So it should be the smallest, which we see to be the case.